Thank you everyone for coming for this panel discussion, and the panel is on the topic you can see on IoT and AI will develop revolutionary solutions for critical global problems. So this panel is organized by Dr. Sandeep Ray from University of Florida and myself, Himanshu Thapliyal from University of Kentucky. I will be moderating this panel. We have 5 eminent panelists today, and Dr. Kemal Kaya from Florida International University, Dr. Sarup Bhunia from University of Florida, Dr. Jinkao Lee from Lime, Dr. Saraju Mohanty, and Dr. Dan Zhang from Google also. So we have eminent panelists. I would like to give you some brief idea that when Dr. Ray was planning this panel, what was the thoughts in the mind. So you can see that, last several years, there have been phenomenal growth in IoT, cloud computing, and all those things. And then artificial intelligence is also coming into picture. So it is interesting to see that how the IoT and AI can converge together to solve some of the global problems. And so today through these panels, as we discussed that the panels are very prominent person in the field. So we thought of having their opinion in some of these interesting problems and what they think about this convergence of AI and IoT together actually. So with that, without taking too much time, I will try to introduce our first panelist. And I will read the bio. Dr. Kemal Kaya is a full professor in the Department of Electrical and Computer Engineering at Florida International University. He received his PhD in computer science from University of Maryland, Baltimore County in 2005. Dr. Kaya leads the Advanced Wireless and Security Lab in EC department. His current research includes security and privacy, Internet of Things, and cyber physical system. Dr. Kaya is also the founder and director of first bachelor degree in IoT in the US, and he is the editor of Elsevier ad hoc networks and also serves in various editorial boards. So with that, I would like to welcome Dr. Kaya to present his view on this topic.
Thank you, Himanshu. Do you want me to share any slides or?
Yes, it will be great. If you have slides, please go ahead. That will be nice.
Okay, let me try to share.
Top right.
Yeah. So can you see the screen?
Yes.
Okay. Great. Thank you again for inviting me. I would share some ideas on the general topic and some questions that you posted. So before I start talking about the applications that are realized through IoT and AI, machine learning, I want to show you this IoT infrastructure roughly that is applied within the current systems. So this evolved through the years. Of course, it started with the, this intelligent sensors, small, tiny devices, but now we have this mature system where we can say that there are 3 layers. And through these layers, we can realize a lot of interesting applications that touch our lives. So at the bottom layer, there is lots of sensing devices, IoT devices, senses information and provides data to us. And this is sometimes called perception layer. And then the data needs to travel through an infrastructure, through internet. It goes to a gateway. This is actually the connectivity layer or network layer, which relay your data to a remote location, which is the 3rd layer, application layer, where you can store the data in cloud or wherever you want. But typically it's the cloud now that stores a lot of IoT data, which gives us the ability to analyze that data and ability to apply machine learning and AI, etc. So this is actually a perfect example where we see IoT and AI coming together. So we have that ability to sense a lot of things, and we can collect a lot of data and now analyze that data. So the IoT and AI is already integrated in the current modern IoT infrastructure. So this integration enables us a lot of powerful applications already happening or may have the potential. So you can start, sensing any system from humans to, you name it, planets, and you can collect data from these systems, and you can analyze that data to offer solutions to some really significant or acute problems that the humans are facing today. I listed here some examples to show that there are really powerful use cases for IoT and AI. So I want to offer them first, but later I want to mention that this is just a tool for us. So it will be a exaggeration to claim that we will have solutions to many of the really big problems that humanity is facing. So if you look at health, for instance, this is one of the main problems that humans face in terms of sicknesses and the aging issues or life expectancy. So this is a place where wearable devices can play really a critical role to collect data in advance and enables us to do predictions. And there are really nice machine learning applications which can predict whether you will get cancer or not in the future. So these are really accurate. And this is actually a very powerful tool to take action in advance and hopefully come up with medications so that we can increase the quality of life and life expectancy. Similarly, for environment, the global warming, pollution, farming, a lot of applications can benefit from these technologies that really affect a lot of people. Transportation is similar. We have traffic congestion everywhere in big cities, and again, IoT and AI will have a prominent role here, and already having that role actually. And we're talking about automated vehicles, which will change the way we understand transportation, driving, parking, and these will be really helpful in many aspects. So, as I mentioned, these are really useful when you look at it from one perspective, but from the other perspective, a lot of problems that we face, the acute global problems, involve human beings. So if you look at the list of global problems that the humans are facing, you see a lot of the list that I just put some examples like poverty, conflicts, gender equality, corruption, drugs, human trafficking, etc. So the problems to these, the solutions to these problems will largely depend on human willingness to share, respect, and care one another. So technology is just, a tool, and as long as you don't use it for your benefits, you will not have any outcome, any valuable outcome here. And there are many other problems where IoT and AI may play instrumental roles. But again, I think it comes to these roadblocks that are related to humans, related to costs, related to accessibility. So, for instance, if you look at the IoT technologies right now, they are not available to masses. And we see smart home technologies, the devices that are available to people who can afford them and use them for their conveniences. But they're not available to poor people. Like, if you want to use them in education in Africa or farming in Africa, it's not easy to deal with this resource problem. And the business mindset here drives the domain. So companies would like to make money out of IoT, and we see products targeting high-income people. So probably there needs to be a shift there where we will somehow offer these IoT and AI technologies to people who don't have access to it traditionally. Of course, this is a separate issue. This is a policy issue, perhaps, and maybe governments need to deal with this. So once we have that equality of access to that technology, then we may see a lot of impact. I can tell. Like poor people will have access to this technology, which will make life easier for them. And this will be really a big impact and solve a lot of issues. But in summary, I think I can tell that yes, these technologies are powerful and useful, already happening. But if we cannot address the issues that are mostly non-technical, then it will be a hype that these technologies will offer solutions to many of the problems that are listed here, global problems. So I guess I can tell that I'm in the middle. So yes, there is potential, but not technological parts are not enough. So we should still need human willingness and other policy contributions to make this happen. So I will stop here. It's just, I guess, I don't know how I did in terms of time, but I'll be happy to answer questions after.
So, thank you, Dr. Kemal. So we'll move to our next presenter, and then we'll take the questions. So our next presenter is Dr. Sarup Bhunia. Dr. Bhunia is a preeminent professor and director of Warren B. Lamb's Institute for the Connected World, and he's also Simato Chair Professor of IoT in the Department of EC at the University of Florida. And Dr. Bhunia has earlier served as the TNA Scrodier Associate Professor for ECE at Case Western Reserve University. Dr. Bhunia has written over 250 publications in peer-reviewed journals and conferences. And he has interest in IoT, hardware security, and he's serving in IoT boards, including the EIC of Journal on Hardware Security and several top-tier conferences. So with that, I'd like to welcome Dr. Bhunia to present his views.
Thank you, Imang. So can you see my slides?
Yes.
Okay, wonderful. So I was telling Sandeep right now that faculties cannot give a 5-minute talk. So that's probably a mistake, but I'll try. So this is a question which I believe is a very profound question, whether IoT and AI will be able to revolutionize technologies to solve critical global problems. And interestingly, I'll try to answer this question first before I can go into some details. But interestingly, this is a question which we are looking at Warren B. Lamb's Institute for the Connected World at University of Florida. So I'll give you some examples on how you're trying to address global problems and what the promises are. But my answer to this question is pretty simple. Yes, it's a real promise, and I understood that Kemal didn't want to take a position, didn't want to take a side, but I will take a side. It's a real promise because I believe it's a promise, and not only it's a promise. I will go one step further. I will say, hey, it's a part reality. It's already IoT is helping in solving many global problems. In part, of course, there's a lot of room to innovate, a lot of room to basically use IoT for solving practical global problems in many different ways, to basically leverage the potential of IoT to its fullest. We have to do more, but it's already a reality. And the reason it's a reality, I'll talk about that. is because number one, IoT deals with data, and data is the future, and number two is that IoT integrates with cell phone network, and which is something which is available everywhere across the world. So before I go into some details, I'll talk about the institute I belong to. This is called Warren B. Ames Institute for the Connected World. It was established a few years ago with the goal to explore IoT technology and IoT applications in diverse areas. And it has actually a mission. And interestingly, that mission is very much aligned with the topic of today's panel. We have a strong leadership team. It was established through generous donations of our alumnus, David Names and Sachio Semoto. And in the institute, we are collaborating with a lot of faculty members. Right now, we have 53 faculty members, 100 students, and we are looking at partners, collaborators, and sponsors for further engagement. Before I try to expand on my answer, I would like to set the ground a bit. I know that Kemal did do a good job in establishing the ground, but I'll still go over it quickly. What is IoT? And in this particular case, we're talking about IoT and AI. And I would say, hey, we are looking at AI-enabled IoT or AIoT or edge intelligence, whatever you call. The basic idea here is that you take the traditional good old embedded systems, you add generous amount of connectivity. It's like a recipe, and then you add smartness into it. Smartness means it can now have some autonomy in it, and it can make intelligent decisions based on the data it collects through the sensors on board, and then basically to make it interact with other IoT devices, you have to add interoperability to it, and that makes IoT, which we are looking at. As I mentioned, the question is very profound because IoT itself is extremely profound in terms of the technology backbone as well as what it can do. And because of that, because of its profound capability, it's actually being deployed in many different areas. And as you all know very well, the number of IoT devices is growing exponentially. By one account, this is 24.1 billion by going to be to the 24.1 billion by 2030, and it's transforming our industry and also transforming our life in many different ways. Now let's try to answer what are the global problems. There are just too many problems today. Even if you set aside the political problems, there are just so many problems in the disease we are facing. You know the pandemic very well, in the healthcare part, supply chain, climate, food, water security, and all those things. The problem is so severe that our fellow human beings who are rich, they're trying to look for potential relocation in Mars or outside the world. So it's definitely an interesting time where humanity faces significant challenges globally, and we'd like to see if the technology can come to the rescue. The answer is yes, it can come come to the rescue, and I will just give you some examples which we are looking at the NAMES Institute for last several years. And one of them is to deal with the pandemic. It turns out that we can come up with smart connected wearables, which is exactly what we are looking at the convergence of IoT and AI to deal with the pandemic for protecting and mitigating the effect of the spread. And I'll not go into details about that, but if you're interested, we'll be happy to take a deeper dive later. IoT can help with the supply chain. IoT can help with making sure that what we consume, what we wear, and everything are safe and they are not contaminated. I'll not go through details about that, but IoT can also help in terms of making our environment and climate sustainable. And that can be done by making smarter drones, smarter monitors, smarter sensors, which can be used for environmental monitoring. As I mentioned, convergence of IoT with AI can lead to new possibilities, and I do believe that can affect the overall well-being of mankind by solving a lot of global problems. Thank you.
Thank you, Dr. Bhunia. So now we'll move to our next presenter, and Junkao is the head of hardware at Lime. His team designs Lime's hardware from scooter to e-bikes. He also manages the supply software engineering team. The team develops software to help manage and operate Lime's fleet at the scale of 100,000. Zhang joined Lime from IB, where he was the head of engineering for offline retail business, including both store and mall scenarios. Before IB, he worked at Uber as an engineer manager in teams from dispatch, infrastructure, airport to business automation. So with that, I'd like to welcome our presenter Zhang for to present his views.
Thanks for introduction. Not like other professors, I don't have slides, so I'm going to talk through some of the experiences we have at the Lime or some of the challenges. To start with, I want to start with introduction about Lime. Lime actually is the largest micro mobility provider in North America and Europe. So we operate hundreds of thousands of vehicles, including scooters, e-bikes, and mopeds in those markets. At Lime, we believe micromobility is the key to solve some of our global challenges, such as global warming. And I'm not sure how many of the audience has been visiting our top cities, for example, Washington, D.C. and Paris. I was in D.C. last week, and I can see like bikes and scooters were in such a high demand. Like you really cannot find available scooter on the streets past the one. So with that amount of usage on bike and scooters, we are definitely going to reduce the usage of gasoline cars, and in other words, reduce the CO2 emission and improve the overall global health, right? So with that context, I want to start to talk about Lime's challenges. First of all, in my opinion, I feel like the combination of IoT and AI is really like a need from the industry point of view, and it's helping improving our life every day. And we are having a lot of challenges that need to be solved in order for us to scale at larger magnitude. So a few of our observations from Lime, right? First of all, as you all know, like we have hundreds of thousands of vehicles on the street that is operating right now, and each one of our vehicles have a way to connect to our cloud services through an IoT device that is on board of the vehicle. And when you're operating at such a large scale, it's guaranteed that on some places in the world, you're going to have an outage. You're going to have like vehicles not accessible to our backend. What it means to our customer is that it's not reliable, right? When we have vehicles in from their door, their house that they cannot use, it becomes a reliability challenge for them. And also for Lime, it hurts our revenue as well. So we are getting a lot of like feedbacks from our local general managers to say we need to improve the reliability of our IoT infrastructure. And the second point I want to talk about essentially is from the safety point of view, right? We at Lime use a lot of AI technologies on board to improve the safety of our riders and also the safety of our other citizens. A few examples. One of the things we utilize AI on our devices to do is to detect whether the riders are riding on the sidewalks, right? In many cities, sidewalk riding are explicitly forbidden because we have seen accidents before when riders ride a bike or scooter on the sidewalk, it run into other riders and cause fatality and even injury sometimes. So what we do is we use several technologies. We use sensor technology we combine like GPS data and some other sensor data to decide whether a rider is riding on a sidewalk. If we determine so, we will give the rider some warning or even disable their rides. And meanwhile, we are doing some CV, we are studying some CV technologies that we can use our cameras that is placed in front of the scooters or bikes to decide whether the rider is currently on the sidewalk. Another example of the AI technology we're currently using our vehicles are moped, right? So we are adding a rider-facing camera to our mopeds that can detect whether the rider is wearing the helmet. If they are not wearing the helmet for the safety concerns, we're going to warn them and make sure that they keep their helmet on the whole trip. A third example is incident detection and AI and log analysis. So we understand it is safe for our riders when they ride our scooters, right, our bikes, right? And we also want to know in first hand when they fall, right? So this is also doable based on our IoT logs, where you have service built on back in 9, where we analyze the IoT logs, and based on our sensor data, we know some trips the riders may have fall. It may not be the rider fall down, right? It could be just like the scooter or bike to get fall down while rider is taking a photo, which in those cases is fine, but we just want to be double sure and to be aware of those incidents upfront, and also outreach to our riders to check if they're okay. So there are many examples that we are applying AI technologies on our IoT devices. A couple of new ideas actually we're exploring right now, right? Like we know, like we are adding cameras to our devices. One of the ways we can utilize the cameras is to do localization or based on cameras. I'm not sure how many of the audience has been using one of the service from Google app. When you try to navigate yourself when you walk downtown, right? Like GPS can be very inaccurate because of the GPS signals can have a reflection effect on some of the buildings, high-rise buildings in the downtown area. So in this case, the computer vision-based technologies can be very useful to identify current location very accurately within a meter. And we're actually using that right now and integrate to our systems. Another example is that we are utilizing the computer vision technologies on vehicle cameras to decide where are the vehicle location itself, right? For example, one of the challenges we had, again, it's from the citizen to our cities, is to ensure when the riders park the vehicle, they are at a certain location where they are better organized instead of being like scattered throughout the city. So a foundation to that functionality is we can make sure we have the vehicle parked at the right place. GPS a lot of times cannot give us this accuracy that's needed. Usually, by our experience, GPS can only give you like accuracy of 8 meters within the city territory. But when we combine the technology of computer vision on board of IoT device, that can improve the accuracy of the parking within centimeters. To our latest data, is like 30 centimeters. So that's another example of how computer vision is helping Lime to do better parking and locating our scooters or bikes on the street, and in turn makes our life better in the city because no one likes the scooter and bikes to be parked everywhere. With that, that's mostly my talk. Like to conclude, right? I really feel this is IoT and AI technology combined is making our life better and better every day, and certainly we need it, and we need to have them improve that as a fast piece. So with that, I'm going to hand it back to our host.
Okay, thank you. Thank you. Our next speaker is Professor Raju Mohanty. I hope you can see my screen. And let me see. Yeah, let me see. Can you see my screen or not? Let me share my screen one more. Okay. So yeah, so our next speaker is Professor Raju Mohanty. Professor Mohanty research is in smart electronic system, which has been funded by NSF, SRC, US Air Force, IU, SSTF, and Mission Innovation. He has 20 years of research experience on security and protection of media devices and system. He introduced the secure digital camera in 2004 with built-in security features designed using security by design principle. He is widely credited as the designer for first digital watermarking chip in 2004 and first the low-power digital watermarking chip in 2006. He has authored over 400 plus research articles, 4 books, and invented around 7 patents. His Google Scholar Index is 42 with over 7,600 citation. He is the recipient of 13 Best Paper Award, Fulbright Specialist Award. He is also in the Consumer Electronics Board and also the CS Distinguished Leadership Award he has received in 2018. So with that, I'd like to welcome Dr. Mohanty to present his opinion.
Thank you, Himanshu. So already 3 or 4 of the panelists have presented their views. So my view, I'm in the middle ground actually. So I think IoT has done a lot of things for us, and still IoT needs to be redesigned to accommodate a lot of things. So how I started getting to know IoT myself is when I was doing smart cities related kind of reading. That when I was reading, I came up with the 3 I's, what I called instrumentation, interconnection, and intelligence. And I think IoT provides all these 3, so that's the positive side. And both smart cities and smart villages, the components they have, for example, waste management to smart energy, smart parking, and healthcare, all these are essentially because of the IoT. So IoT is playing major role. And one example of IoT application is what I called as Internet of Medical Things. And in a bigger picture, one can comprehend called healthcare cyber physical system, where various healthcare basically mechanisms are possible, automated with the minimal usage of healthcare professionals. Our group has been doing a lot of work in this area, particularly on diet management, stress management, and also detection of seizure. All these areas we have been researching for last 5 years or so. So this is an important application what IoT has done for us. Additional impact I see is in the agriculture domain, where in fact July 21 issue of Consumer Electronics magazine is dedicated for this, where IoT is helping starting from crop management, irrigation, then water quality, livestock management. All these things are possible because of IoT. And we coined a term Internet of Agro Things, just similar to Internet of Medical Things for healthcare. And IoT, definitely the importance of IoT is very well observed during this pandemic for both healthcare and agriculture domain. To talk about AI stuff, when we are using the word smart, smart is coming because of aggregation and analytics of a lot of data, and justification of that amount of data is probably okay in the smart cities context, where people can have a lot of basically budget to accommodate such kind of data. They are post-processing and they are modeling. On the other hand, in the case of smart villages, probably justifying those kind of time and resource for training of AI models and then running of the AI models is difficult. And as a result, some concept called TinyML, or Edge AI essentially is coming to picture, which needs to be much more rigorously done. And there will be some accuracy loss because of TinyML or because of Edge AI, but cloud-based AI compared to that, Edge AI have much more promise in the healthcare domain and smart village application. And more work needs to be done this. And to facilitate basically this kind of with a reasonable amount of data and quality data modeling, we have introduced a new computing paradigm, what we call as a collaborative edge computing. The idea is simple. Let us say there are 10 small villages with minimal computational resource, and when they work together, 10 of those villages, they can potentially have a distributed edge computing, which work together to process a reasonable amount of data and develop reasonable models. So in this paradigm, like where we put intelligence in the IoT, whether at the end device, edge device, or cloud, depending on the application, this needs to be well addressed, and basically so that this will be applicable in the village as well as cities area. Another thing that I see, like people talk about blockchain, and blockchain is not that simple thing that people easily talk. It has its own energy price to pay. And if we want data to be processed through blockchain, that means that the blockchain is storing the data and doing some sort of privacy assured modeling, this and that, then either IoT has to be redesigned to match the resource requirement of the blockchain, or blockchain has to be redesigned to run in IoT. So in that context, we have done, actually we have done some, and also a few of my students are right now engaged how to improve the energy requirement and reduce the resource requirement of blockchain. So in that, we introduce one idea, what we call pop chain, where most of the security aspects are taken care of by a chain of pops, and then blockchain as a whole is either doing the data management or storing off-chain data. That's the idea. And this is one situation that IoT and AI-driven any IoT company paradigm that needs to worry about. That is, if quantum computing becomes a mainstream computing and they can break any level of encryption, then how we can provide IoT security to the end device and edge device, which are less computational intensive. And as a result, some new paradigm, what is called security by design, privacy by design, needs to be explored, which is at a very early stage, even though time to time I have been using the term called hardware assisted security, security by design, but still a lot of things need to be done where we can make security as a design habit instead of retrofitting. So, and this is my challenge, that is, okay, IoT, connectivity, data, okay, all these things are there, but think of a situation where there may not be any internet and there may not be electricity. So how do we run AI? How do we connect these things to claim that we can have a feasible IoT? So those are challenges. And probably an answer is certain extent some energy harvesting with supercapacitor battery may be there in each of the sensor nodes. So, and in this respect, we have explored an idea. This was done by NIT Rourkela people, what we call as eternal thing, which is doing energy harvesting as well as providing security. And this is another idea that is available in early access, personal IoT. Personal IoT, that means using local connections, how to have minimal IoT available, so that at least like as a personal domain, some healthcare and other things can be taken care of. And this is the big challenge that I was just saying, when there is no connectivity, okay, whether IoT can help, AI can help, okay, and this gap, like formal versus informal city, it can be met. So with this, as I said, I'm in the middle ground. IoT has done quite a bit, but still a lot of things need to be done. Thank you.
Thank you, Professor Mohanty. So we'll move to our next speaker now. Just give me a minute. I will share my slide and. Okay, so our next speaker is Dr. Dan Zhang. He is a researcher at Google Brain on the ML for System team, where he currently leads a joint effort to use ML for hardware software co-optimization targeting ML accelerators. Prior to Google, Dan worked at Microsoft on hardware architecture for the Brainwave FPGA-based data center accelerator for ML interference and was the primary developer for the Catapult FPGA open source academic program. Dr. Zhang received his BSc degree in computer engineering from University of Michigan and his PhD degree in EC from University of Texas, Austin, advised by Derek Geo. So with that, I'd like to welcome Dr. Zhang to present his opinions.
Yeah, thank you. Yeah, and very excited to be here. Like some of the presenters, I don't have any slides. Also, I'll try to shorten, I guess, my position station a bit so that we save some time for questions. Yeah, so like a lot of presenters, I would say that I'm in the middle ground. IoT and ML are a very exciting piece of emerging technology, but are not a magic bullet. They will not automatically cure all our problems, so to speak. So my background is more on the ML side rather than IoT, so I'll talk a little bit more about that. So ML, as you know, has recently gained a lot of steam, a lot of hype, a lot of investment, starting from the early days of optical character recognition, moving to handwriting detection, and eventually being able to tell the difference between a cat and a dog. And now has taken over a role in many, many different categories. So just as a word of advertisement, I'll be talking about one such example of this tomorrow during my keynote, where I'll be discussing how the ML for Systems team within Google Brain has been using ML to basically hopefully eventually change the way hardware is being designed, computer chips are being designed. So our goal on the ML for Systems team is to build the framework necessary to eventually be able to get to a point where we can truly automate hardware design. So currently, ML accelerators, as you know, take let's say 2 to 5 years to develop, and may require hundreds or even thousands of engineers working on architecture, RTL implementation, verification, physical design, etc. It's a very time-consuming, laborious manual process. So we're looking to automate all parts of the stack. Recently, we had a publication in Nature about using reinforcement learning to do floor planning. And currently, as mentioned in the bio, I've been leading an effort to look at to expand design space exploration, or to look at how we can automatically search many aspects of the stack, including the hardware architecture, the software compiler, including scheduling and fusion decisions, in order to build custom accelerator designs. So a lot of interesting work, not just really in system design, but elsewhere. Self-driving cars, that's the thing that's starting up. ML has been extremely integral technology there. For detecting vision and yeah, but I guess like although there's all this promise, right? There's also the human component, as mentioned by other keynote speakers. The world's a very complex place, and I also want to talk a little bit about some of the key challenges that we need to surmount on the ML side, right? So with it might sound cheesy, but with great power comes great responsibility, and as people who are as stewards of this technology, at this emerging space, we need to be cognizant of the human impact which may result based on the technology that we invent, right? And so I want to talk about a few of these. So one would be, as you know, these models that we're building, they're getting very large. And people have found, right, that, for example, with GPT-3, with the Google Mina model, which recently came out, that these language models can scale. And when you scale them to extremely large sizes, for example, multiple billions of parameters, you may start to get some emerging behavior which resembles, which can pass the Turing test in some sense, right? So you, like for example, with the Google Mina chatbot, you can have real human conversations with it, and it may seem like you're actually talking to a real human. Very exciting stuff. But where are some of the challenges of this, right? So one is the as you scale these models, right? This is, first of all, extremely expensive to train, not just from a machine standpoint, in terms of the number of machines times the amount of time that you need to train it, but there's also the environmental and cost considerations. So people like to measure, for example, what is the cost to train a model in terms of CO2 consumption, right? And it turns out when you're building these huge models, it can take basically some truly mind-boggling amounts, right? And so Google has obviously spent a lot of time trying to address this. For example, most of the Google data centers right now are green, and Google has committed to moving all their data centers to renewable energy resources. But that doesn't mean we can just simply waste energy and resources just because it's renewable, right? So that's one key aspect, right? How can we build these huge models, or models which get performance similar to these huge models, but do so in a way that is more cost efficient, right? So more efficient ML models. So secondly, of course, as humans, we're the ones who are creating these models, and so it's frequently the case that because we want to find the most convenient data sources. We want to do what we know best. That will encode some of our own personal biases towards these models. And so one key aspect is the data sets that we use. For example, training these large language models, are we using high quality data sets, or are we using just random data we're finding on the internet, right? Are we, like, for example, are we going to Reddit, and then there's a lot of for example, sexist and racist, et cetera, incorrect facts as well, like on the internet, right? And if we train our models with data containing these facts, then it may be the case that our models may learn some of these bad habits, right? So how can we prevent our models from speaking? How do we ensure that they speak the truth and do so in a very fair way, right? And of course, it's not just the data. Some people can claim that the data is the only thing that matters, but that's actually not true, right? Because, like, for example, you think about it, if you have a training set, and let's say that your model is biased towards a minority of the population, let's say 1% of the total data set, right? And let's say that it performs worse on that 1% by, let's say, 50%. Well, what happens is that your total aggregate score will reduce by 0.5%, right? Which is the 1% times the 50%. Now, so what this shows, right, is that if the minority group is very small, then the model actually, it's very hard to detect, right? Just from the aggregate score where these biases are encoded or not. And so you actually need your cost functions or your reward functions to kind of reflect this during your training, so that you can ensure that your models are not biased. And of course, these are not the only problems as well, right? So with self-driving cars, for example, previous research, so self-driving cars depend on vision as a key component of detecting what's on the road, right? And we know that in the past, at least, people with darker skin tones have had trouble. These computer vision models have had more trouble doing facial detection and everything like that when looking at people with darker skin tones, right? So obviously, this is something that we want to avoid as well. And with huge systems like this, it may be the case that, for example, you can use other technologies besides just vision to supplement in order to avoid these biases. For example, you can use LiDAR, sonar detectors and things like that, which don't really depend on the visual characteristics in order to detect humans. And so there's a lot of huge problems that we need to face, but I think that as long as we're cognizant of these problems, and as long as we put significant investment, we can definitely address these challenges and ensure that the technology that we create is going to be useful and beneficial for everyone. So that concludes my keynote, my position.
Okay, so thank you. So thank you, Dr. Katkuri. How much minutes more we have? So based on that, we will plan the post Q&A.
Yeah, we can go another like 10, even 15 minutes. That's okay. That's a break. So
okay, sure, great.
The parallel session. So yeah, we can go another 15 minutes. Yeah.
Okay, sure. I will note the time. Okay, great. So thank you, panelists. And with that, I like to give an opportunity to the audience. If they have any questions, they can type in the chat window, and I can ask those questions on your behalf to our panelists. So if you have any questions, don't hesitate. Please type in the chat window, and I will keep reading the chats. And if you have any question, I will be happy to ask those questions to the panelists. Okay, so let's start some kind of a conversation. So recently, I was listening to one documentary, and one of the documentaries says that Microsoft was trying to use AI and IoT in such a way that the animals can be saved from the poachers. For example, you can use AI so that when the poacher goes there to kill the animal is not there. So in other words, you are tricking the poachers that through using AI and IoT so that the animal is getting saved, right? So can you show some other examples from your other perspective, what you think where IoT and AI can be combined together for the global impact? I know you have addressed some of this, but some of them which could be like real world applications also.
So maybe I can start, and there are just thousands to millions of them, these applications, and maybe I'll just quickly talk about a couple of them. I know my co-panelists have a lot more to talk about, and this is something which can go on. So one of the examples which I have seen recently is that drones equipped with the AI techniques, particularly complex computer vision, can do a lot of interesting things. They can detect forest fire at the onset. They can actually localize specific part of an agricultural field for invasion of insects, and they can even tell you what kind of insects they are. They can potentially also mitigate by spraying the right kind of insecticide to those regions. This is called precision agriculture, and AI combined with IoT, or the convergence of AI and IoT, are solving those. Some of the examples which have really intrigued me are recently there is a group I collaborate with. They are working on a project in India so that they can use AI and IoT to monitor mosquito populations, and they can potentially track them, prevent their growth and spread, and thereby prevent the spread of dengue and other disease. So yeah, I'll stop there, but there are just too many of them to talk about, and that's why I mentioned that this is a real promise, and in part it's reality.
Great. So any other panelists want to put some opinion there?
I think contact tracing during pandemic, for example, COVID-19 we are now dealing with, right? So how we can have some sort of, whether you call it contact tracing or some warning, so that if you know you are close to somebody who is infected, then you can get a warning. So in that, we experimented one idea called Easy Band. Okay, that was for that purpose. So it's either GPS or some Bluetooth and other connectivity it is having, and kind of using some warning.
Great. So I have one question for Dan actually, because you talk about ML things. So let's say when you're driving a car actually, and or let's say something like that, and then you want to do some like the AI and the machine learning at the edge, right? Because you want to recognize the driver and all those things, right? And sometimes you want to connect it to some 5G or something like that to make sure the authentication. How will you handle those scenarios? Suppose you don't have the good bandwidth there.
Yeah, that's a great question. So I would not consider myself a self-driving car expert, but I will try to answer. So I think a big part of it, right, is that you need enough compute at the edge, right? So the car itself needs to be able to support at least momentary lapses in which like it loses connection to the overall network. And in fact, it really, and I think this is also important from a security standpoint, right? You may imagine that there are hackers, right, who perform denial of service attacks, which may, for example, take down the network. When that happens, you don't want all your cars to crash, right? That would be very bad. So whatever algorithm you or heuristic you design, right, must be able to be fully autonomous and have some sort of fail-safe mode, right? So you may imagine a scenario where, you know, perhaps if you're connected to the global network, each car may be aware of, for example, its surrounding neighbors through the global network, and may even be able to change its route and plan accordingly. Miles ahead of for example, of an accident, it may reroute. But if this network is gone, it still needs to be able to for example, have a cache of the road networks ahead. It needs to, for example, be able to fully, detect all this its surrounding. It needs to be able to, run the full-powered model, right? You should not have a drop in security, or in the worst case, perhaps while we're still, building up this technology, maybe it can notify the driver and fall back to some fail-safe mode where the driver can then pick up the reins, right? I guess just some high-level thoughts.
Great. So any other panelists want to thought, and then I have a few more questions for that. For example, actually, a lot of our panelists work on the security areas. So what is your opinion on like using AI for edge security or security for edge AI, right? So what do you think, like how these two things can play a role actually?
Probably I can I can tell something here as a security researcher. So at the edge, we use AI, the IoT devices, mostly to collect data and to interact with the environment. That's the first line of defense, actually. So now there's a lot of trend towards applying certain machine learning algorithms for sort of intrusion detection, and AI or ML has a big role here. Of course, that takes us to the challenge of running this, I think Mohanty mentioned tiny ML. So we don't have enough resources at the edge, so we can still run some sort of machine learning, but it may not be that accurate. So that's a great area of research. So there is a lot of developments on that side as we have more IoT applications. But the other part is also true. Like when you run machine learning applications, you want to make sure that there is no adversarial attacks during training phase. So that needs to be watched as well. So I guess it's the broad question of adversarial machine learning research, not just AI, not just IoT devices.
Any other panelists want to take a thought on this one? We have more questions from the audience. One of the questions from Professor Jürgen Baker is that, and I will read it so that you get chance to. So the question is that IoT uses AI and AI uses IoT. Thus, which of the two is the real enabling technology? AI of them is the real enabling technology. Second portion of the question is that which will survive, or are both on the same importance? Or if none of them, then what will be the next?
It's excellent. So Dan, maybe you want to go, so then I can.
Yeah, I don't want to fight with my fellow panelists, so I will not claim that AI will survive or something. I think both are orthogonal, complementary technologies, right? Like AI can exist without IoT, and IoT can also exist without AI. I would say that IoT is a great platform and a great enabler for implementing different types of for enabling new AI applications. And I think both will survive, right? I mean, like if you look at the definition of IoT, like it's just smart devices, permeating the landscape, and of course we're still going to have that. And AI, I think we all know where AI is going as well. So I think both are survive, and both are very important orthogonal areas at the moment.
I have same answers basically. IoT needs AI. AI also uses IoT. Like for example, let us say in IoT do different things to take some sort of decisions or some sort of automation. We need AI, and to develop AI models, we need sensor data and other things. So both are equally important, and both will be surviving. Otherwise, we will not have any smart system.
But I would add that AI systems were there with data, working with non-IoT data in the past, but IoT with like using AI is a like more emerging technology. I think we will see more, because we want to have more autonomy for IoT devices. So that means that we will need more AI working within the IoT devices. So that's a more, I think that's an area that with more potential I can see.
Any other thought from Professor Bhunia? Do you have any thought on this one?
Yeah. This is a very very interesting question. So I would agree with all my co-panelists. So these are two extremely promising technologies by themselves, but when you convert these to promising technologies, you see magic. And this magic is going to enable us to solve a lot of problems which we have not been able to solve. And this magic is coming from the fact that, as I jokingly say that the AI is providing the brain to the IoT. I mean, IoT was already there. Right? Even without AI, IoT was very capable, particularly in industrial settings. IoT was doing great. But the convergence of AI and IoT, which is leading to this new field called AIoT, or artificial intelligence of things, is promising a better future, better capability, and better problem solving ability for the mankind, and that is here to stay.
Great. So I have one more similar type of question. So for example, nowadays, if you see, many people are using wearable devices for the healthcare applications, right? But the issue with the wearable device is that you use them for a few days and after that you don't use them, right? So let's say you buy a Fitbit, you want to use it for some time, you want to track it, but let's say, are you still wearing it after 2 years or 1 year? Maybe yes, maybe not, right? So how can this IoT and AI can play a role in human intelligence or making people convinced that wear your wearable devices or something like that? What do you think about it actually?
And Himanshu, after that, there is a question from audience. Okay. Yeah.
Okay. Sure. I will read the question. So yeah. So any panelist has any thought, like how can we make this use of this IoT and AI together to make them wearable device really using in for longer run or something like that?
Actually, there is a society in IEEE called social impact aspect that discuss, right? I've read some of the articles, and also in our magazine we have a department for them allocated 6 pages per issue. So I read those. So from them, what I see, people most part of the world actually don't like wearables. Okay, we see because we are maybe a little bit tech savvy or whatever, but a lot of people don't like. Okay. And that article, in fact, said they were surprised that in India, they go to different part of the world. Okay, in India, they said 60% people they approached, they are okay with wearables. Okay, but in US and Europe and so on, they said a lot of people don't like the wearables. So that's it's a very difficult problem that comes from the way. For example, right now, a lot of people don't take vaccine. What can you do about it? Like that. Okay, so it's not just technical problem or not necessarily technological solve it. It's a mindset. Okay, and it's very complex. So the question is valid. I understood the question very well, but I don't think we technical people can solve that problem. That comes ethical aspect, social impact aspect. They have to convince people.
So I'll quickly augment to what Saroj mentioned. One important thing we have to understand is that what the wearable is doing for you, right? Is it just giving you some email alerts or giving you ability to read whatever you can do, the text messages, whatever you can do in your cell phone already, right? So if that's the case, or maybe added with that some healthcare benefits, then it's not really attractive. But wearable, if you use them in the right way, can really make significant changes. And I'll give you an example. There is a new brand of wearables called CGM, stands for continuous glucose monitoring. And this is basically a life-saving device for people who have diabetes. Why? Because it can continuously monitor glucose in your body. And not only that, it can give you glucose excursions in real time. And not only that, at the end of the month, when you visit to the doctor, it can give the doctor the data for that whole month. Now, this is an unprecedented capability which an wearable can provide. So if you think about those use cases, yes, wearable can be making a huge changes, and you can see more of those coming in future.
Yeah, actually, we have I've worked with a group in India. We developed a device called iGlue, which is exactly what Swaroop is saying, and I just shared an article in chat box. You can see it's a 50-page survey of all the wearables for glucose monitoring we have. Thank you.
Okay. So there is a question from the audience. It says, on the note of adversarial machine learning from the perspective of IoT, do any threats attack specifically stand out in terms of practicality and risk?
Yeah, I guess this is not very different than the regular adversarial machine learning attacks, where the goal is to supply inputs that are wrong or deceptive inputs, I would say, so that the classifier or learner will not learn in the right way that we want. So as long as you mess up with the IoT devices sensing input somehow, this will be practical. Like if you consider, for instance, automated vehicles, like doing capturing the images from the environment and making decisions. Like there was this famous stop sign example. That if you mess up with the stop sign, then it will be interpreted as a different sign, and it will give you a different output. So there are cases where this will apply, but I don't think there is anything specific to IoT. So as long as you mess up with the input, that should do it. That's my perspective, but probably Dan might have other nice examples.
Right.
Yeah, so that example of Kemal, what I gave is excellent example. So if instead of stop signal, stop sign, if it treated as even a slow, go slow, right? Slow sign. Yeah. So that is a measure. I know that example. That's I like that. And also I was thinking like deepfake. Like one of my students works on that deepfake detection and the impact of it in terms of in the news media and so on. Okay, how deepfake it has positive side in the sense probably you can sometimes use fake data to train. That is one way people say as a joke, but negative side that creating deepfake image and video, then misleading the news and so on, that has significant impact.
Yeah, just to add to what the panelists have been saying, in fact, I do have another example. So so I guess one key problem, at least from my perspective, with embedded IoT and embedded devices, is that now we're looking at real world problems, right? And when we look at real world problems, frequently there's going to be examples or attacks which were previously not considered, right? So for example, if you just have like some some mobile applications, right? As technologists, we're already familiar with how this platform can be attacked by bad actors, right? But when we move to a real world environment, like things are completely different, right? And it's very hard for us to kind of predict all the possibilities which can come into play. So one example recently is with again self-driving cars, where I think some white hat hacker or did a simple experiment where they determined that the self-driving cars, or I think this was a Tesla car, was detecting the lines on the road, right? So when you have a double yellow line on the road, that means that this demarcates the directions, right? And you cannot actually cross a double lane. And so what this person did was he drew a ring of double yellow lines around the entire vehicle, thereby trapping the vehicle and not allowing the vehicle to escape, which was I thought kind of funny, right? So you may imagine future scenarios, supposing that something like this is not fixed, where you may actually like draw with chalk right on the road, like an attacker may draw with chalk on the road new road signs, right? And then move, for example, some self-driving truck which is carrying some valuable freight right off the road into some other location, right? So something like this is probably was not predicted, right, by the engineers who probably have thought of many things, but maybe not something like this, and it kind of shows kind of some of the risks and challenges that we face, right? So something like overrides, I think it'll be a long time before humans are completely replaced, right? In terms of even for something like driving.
Great. So I think we will take our last question. The question is more on, like, for example, there are many students also in the audience, and sometimes many of the students look for opinion about from the expert about the research direction. So some of the, let's say we talked about IoT and AI, and possibly one direction could be IoT, AI, and blockchain combined together. So I will ask each panelist to give one opinion about what do you think could be another possibilities of combining IoT and AI with some other possibilities. Like, what do you think? So maybe anyone want to take an opinion on that one?
Yeah, I think when we collect data from IoT devices, we store it on cloud servers, right? Instead of cloud, there may be cases where we can store it on blockchain, because blockchain is providing an immutable environment. So this might apply to government data, local government data that you collect, and for transparency purposes, you don't want that data to be changed or deleted in the future. So you may create a blockchain. It might be permissioned or public, and store data there for future access. And still, it's like a database. You can still run AI and machine learning by using that data, but your underlying infrastructure will be blockchain, and the data supplied there will be coming from IoT. So this is a perfect case where we integrate all of them.
To add that, right now 2 of my students actually working on that. Exactly, we call it a scalability problem of blockchain. That is what we are addressing. Blockchain cannot easily store data. It's not scalable in terms of how much data it can store on the blockchain. So we are coming up with solutions like multi-chain and those kind of things. So we are looking at those. And that's, I definitely recommend, a very good area to work on. And actually, TinyML, I mentioned, that's a very good area. We have to have lightweight machine learning models so that will run even a node MCU kind of hardware instead of, or a RISC-V small hardware instead of running in the cloud. Okay, so those 2 I would say are very good areas. Thank you.
Yeah, I'll quickly add to that. Basically, all these are extremely student researchers. This is a great area to contribute. I talk about 2 verticals. One vertical is IoT technology, which looks into using AI for IoT. And then addressing the resource constraint is one problem. Addressing security is another problem. So there are a lot of cool challenges for the students to address in that vertical, which is IoT technology and the convergence of IoT and AI. The second one is that how this paradigm can enable new applications, and then that possibility is really enormous. There are a lot of areas which has not seen penetration of IoT can now see that because of this new added potential.
Yeah. Yeah, so all the panelists I think have made great points. I think just to add to that, like a word of caution, I guess. So I hope that for all PhD students, right, that they focus on solving an important problem and solving finding the best solution, right, that solves a particular problem, rather than trying to combine multiple different, I guess, emerging hype technologies together and try to force that into an existing onto some problem, right? So not to say that there's no such combination, that this combination is not useful. I'm sure it's very useful, but I would strongly urge all grad students to pick the application first, then find the best solution for the application, rather than finding trying to combine all the hypes and then trying to find a solution for that. Yeah.
That's excellent input, Dan.
Okay, so thank you, everyone. I really like to thank the panelists for their time. I think it was a great discussion, and thank you, everyone. And with that, I like to conclude the panel. Thank you, all the panelists, and thank you, attendees, and thank you, everyone, for the nice queries. Yeah.
Thank you all.
Yeah, thank you. Yeah, thanks for the opportunity. Yeah.
Thank you.